We're now going to look at solving inequalities when they are quadratics. So we're given this equation here. The first thing that I want to do is I'm actually going to set this guy equal to 0. We're going to pretend. The next thing I'm going to do is I'm going to try to factor it if possible. All of these can actually be done by using the quadratic formula if you are more comfortable with it. But this is actually not so hard one to do. We're going to have factors of plus 1 and x plus 3. Whenever we're solving, we have to set both parts equal to 0, giving me solutions of -1 and -3. Now, when it's an inequality, the key thing for us to do here now is to plot these values on my number line. So I'll have a -3 and a -1. And what I'm going to do is I'm going to test what values on the number line will satisfy my inequality. So one of the testers that's a really easy one to do is let's test 0. So if I were to plug it in, I'm going to see if my inequality or my original function will hold. So we have 0 squared plus 4 times 0 plus 3. And I'm questioning whether it is less than or equal to 0. Well, this is just 0. This is just 0. So I'm left with 3 less than or equal to 0. This is not acceptable. This does not hold. So I know that this is not part of where I'm going to shade in. The next thing I'll do is let's plug in -2 because it is a value between -3 and -1. So if I plug in -2 into my original quadratic, we have -2 squared plus 4 times -2 plus 3. Once again, I'm questioning whether it's less than or equal to 0. -2 squared is 4. 4 times -2 will be -8 plus 3. So this guy, 4 minus 8 is -4. And -4 plus 3 is -1. -1 is less than 0. So I know that values between these will for sure hold. Just to be sure, I want to test also values that are less than -3. So let's try -4. -4 squared plus 4 times -4 plus 3. And I'm questioning whether it's less than or equal to 0. -4 squared is 16. So we have now plus 4 times -4, so that's really be -16 plus 3 less than or equal to 0. These go away because we have 16 minus 16. And as we said before, 3 is not less than or equal to 0. So that means I am between -3 and -1. Now if you remember from Unit 1, we have an or equal to part, so these values should get closed circles. All right, another step that you need to do is you also need to write these in interval notation. So what that means is the smallest that I can go is -3, and I can go all the way up to -1. These values are going to receive brackets. Brackets means that I can equal these numbers. It has that or equal to part. All right, we are going to do another inequality together. So my first step here is I need to have this be set to equal to 0. If you're noticing, this is actually the third problem on your packet page if you're in J term. I have 2 terms on one side and 1 term on the other side. So I need to bring my 27x over to the other side and then pretend it's set equal to 0. So we have 5x squared minus 27x plus 10 equals 0. All right, so the first question is if I can factor it. All right, but let's not do this one with factoring. Let's use my quadratic formula here. So we have -b, so we have 27, plus or minus the square root. Need my calculator for this one. B squared, so -27 squared. 27 raised to the second power is 729. Minus 4, my a value is 5, and my c value is 10. All of this is going to be over 2a. All right, so let's start simplifying. We have 27 plus or minus the square root of. So if we type in our calculator, 729 minus 4 times 5, that would be 20, and 20 times 10 is 200. That'll give us 529. All right, so let's see if I can take the square root of 529. Look at that, I can. Always test that first. Sometimes I am nice and I'll give you a nice radical. So the square root of 529 gives us 23. All of this is over 10. So we have the case of 27 plus 23. So 27 plus 23 will be 50 divided by 10. We have the case of 27 minus 23. And 27 minus 23 will be 4 over 10. We can simplify these. 50 divided by 10, that'll give us 5. 4 over 10, that'll give us a simplified fraction of 2/5. These are our two tester points that we need to test on our number line here. So we draw 2/5, and we draw 5. All right, so once again, I had told you that it's a lot easier for us to test this with 0. So let's first plug in 0. 0 minus 0. So if I plug those values in with 0 as x, those will go away. So I'm testing whether 10 is actually going to be greater than or equal to 0. If I just change this back to greater than or equal to 0. And it is. So this part of my inequality will hold. All right, a little key guidance, a key word of some wisdom. Generally, if we are outside on the inequality, the other part of the outside will also be part of my inequality. And the inside will not be. Okay, so I'll assume that it is, let you test it out if you would like to. But now we need to write this in interval notation. We also need to have closed circles because we have an or equal to part. All the way down, 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 down on my number line, I'm actually approaching negative infinity. And I go all the way up to 2/5. Now 2/5 will get a bracket because I can or equal to him part. I can still be him. But negative infinity is going to get a parentheses. In mathematics, infinity is actually not a number. It's something you approach. So he always will get an infinity. But I also got to be this part of this inequality. So I will union together the inequality, my interval of 5. He gets a bracket because I can actually equal him, going all the way up to positive infinity. Once again, he will get a parenthesis because I cannot actually equal that value.